So we are going to work on this example, which is from your algebra textbook. That is College Algebra by Carl Sitz and Jeff Ziegler. So we are given this statement that the cost function in hundreds of dollars to produce X custom built electric scooters is given by this cost function, and the revenue function in hundreds of dollars is given by this revenue equation. And the domain is from 0 to 70. So we have to find the profit function. So if we denote the profit function by capital PX, okay, what the profit function would be? It will be the revenue function minus the cost function, which is x times 140 minus 2x, okay, and then minus the cost function, and the cost function is right here, 1000. So we get this, and this value would be, if you distribute this x in here, you get 140x minus 2x squared. Okay, so what I did was I distributed x over this bracket. Now I'm going to distribute this negative sign over this bracket. So that's going to give us negative 20x minus 1000, right? Okay, so we get negative 2x squared, okay, and then plus how much? How many x's we got? 140 minus 20 is 120 x's, and then we have negative 1000. So this is a parabola that opens down because of this negative coefficient here. Now it says that how many scooters should be sold for maximum revenue. So here we have to take this one up, this equation, the revenue equation, and this is a quadratic equation, and the equation is negative 2x squared. I'm just writing in the decreasing orders of x, okay, plus 140x. Okay, so remember this, for a quadratic function, the maximum value occurs where we take the coefficient of b, right? Okay, and so that occurs at this x value. So take the coefficient of x and divide it by 2 times the coefficient of x squared, which is this in this case, right? So the maximum value of r, okay, is at r occurs at x equals this value, right, which is 140 over 4, that is 35. That means the revenue is maximized by selling 35 scooters, right? And then it's asking for the maximum revenue. So the maximum revenue would be what? The maximum revenue is going to be, so this is our revenue equation. So we will just substitute 35 in here. Okay, so we have 35, then this is 35, and if we simplify this value, what we get is that the maximum revenue would be these many, and remember it's in hundreds of dollars, so that is going to be 2450, then have 100, so $245,000, right? Now it's asking this, that how many scooters should be sold for maximum profit. And this was the maximum, possible revenue. And here we need the, what the sales should be for maximum profit. So let's get back our profit equation here. So we got this, and we will remove this portion here because that was just to use it. So what happens again by the vertex formula? The maximum profit occurs, okay, at x equals which value? We take the coefficient of x, which is 120, right? And of course, there is a negative sign here, okay? And then we have 2 times the coefficient of x squared, that's negative 2. So what we get here is this will be 120 over 4, that it is 30. So for maximum profit, they should be selling 30 scooters, and then it says what is the maximum profit, and that you can easily determine just by substituting 30 in here, and you can just do the arithmetic or go ahead and have your calculator do that, as I'm going to do. And you can use, there's so many calculators, different types of calculators that you all are using. So the maximum profit is going to be, so this is 800. So maximum profit will be 800, and then we have 100 again here. So the maximum profit is going to be $80,000, okay? So this is what we did by working on this by formula. Now, if we go ahead and graph it, then what we will get is, so for graphing, I'm going to use Desmos, and you can just Google Desmos, at this time, like November 2020, and then you should be able to find this graphing calculator. So I have the windows set with from 0 to 70. Now here from 0 to about $3,000 by looking at the nature of our functions. But if you want to revise the window, what you can do is go to the right and just click on this graph setting, and it would let you set your windows, okay? So here I am entering the cost function first. That is 20x plus 1,000, of course, a linear function. And here we have the cost in hundreds of dollars, right? And then I can just put the revenue function, which was how much? X times 140 minus 2x, okay? And you can see that's a parabola, and the maximum revenue is occurring at x equals 35. All right, and this is the maximum point, okay? And then we are going to bring in our profit function, which is negative 2x squared, right? Plus 120x minus 1,000. So this is the profit function, and you can see that the maximum profit occurs at x equals 30 in these many $100 or $80,000 in this case. All right, and you can copy this graph and take it into your document if you would like.